All right, we're going to begin our study of physics by talking about motion, which is also known as kinematics. And we've been studying motion with a motion detector. So we've had things moving in front of the motion detector, and we've had it drawing graphs. So let's explore what we learned from this lab. Before we begin looking at the graphs, I just would like to define two terms that are easy to get confused. One is called the position, and the other one is called distance. Now, to distinguish between these two, let's look at the back of the car here. So the back of the car right now is lined up at 2, and if the car drove down the road a little bit, the back of the car could end up at 7. So we would say the car had a position at the start of 2, and then at the end the car's position was at 7. And then we could say, well, what distance did the car travel? So the distance that the car traveled was it ended at 7 and it started at 2, so the car went 5. So we would say that the position is the location of the car on some reference system, which in our case is this ruler. And so the car can have various positions. The distance is the difference between two positions. So the car went a distance of 5. Now we're going to have the car go from a position of 0, where it is right now, and the car is going to drive along the road here to a position of 8. So that would be a distance of 8. Obviously, this car can make progress along the ruler, can travel that distance of 8 at different rates. So it could go really slowly, or, because it's red, it could go really fast. Now what we would like to do is to describe the motion of this car along this ruler using a graph. So our method is, rather than use words, we wanted to use a graph. So what we did is, instead of using a Ferrari, we used you with a motion detector. And we let the computer, using the motion detector, draw a graph of your motion. So the graph would represent the motion of this car. So here the car is going to go from 0 to 8. So let's modify our graph here to represent that. So we're going to make that a 2, and that's a 4, and that's a 6, and that's an 8. So on this axis is how far the car went, and on this axis we have how long it took to get there. So for instance, when you did this, you saw that as you walked away from the motion detector, a graph was drawn that looked maybe something like this. And what this graph would tell me is that at 2 seconds you were just a little bit short of being 2 meters away from the start. At 4 seconds you were maybe 3.5 meters away from the start. At 6 seconds you were maybe just a little over 5 meters away from the start. And then finally you arrived after 8 seconds at about maybe 7 meters away. Okay, let's look at an example graph. Let's say the Ferrari drove and it made with a motion detector, and so this is the graph that I got. Let's see what that might mean. Alright, so I started off here at 0. So you can see I'm right in the origin. But now, here is the 1, and 1 is like right here. So this graph tells me it took almost 2 seconds to get there. And you can see this is pretty slow, so I'd be like 1001, 1002. So that's pretty slow. And now to get to 2 meters took me like 5 seconds. So I'd be like 1001, 1002, 1003, 1004, 1005. So you can see this graph. So here I am at 2, and like I'm here. So this graph is showing this car is going really, really, really slowly. Now to get to even 3 meters, which would be like here, so 3 meters is like right there. To get to 3 meters, I don't hit that till almost 8. So I'm going to be like starting here going 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008. And now I can see that 4, it takes me 10 seconds. At the very end, I only get to here. So let's see what that would be like. Alright, so that would be 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010. So I have one word for that experiment, and that word would be slow. Now let's say we have the Ferrari driving in front of the motion detector, and it now makes a graph that looks like this. Let's see what that would mean. Well, first of all, the Ferrari is going to start at 0. So we have the Ferrari is starting right here at 0. And now what's going to happen is the Ferrari actually gets to 2 meters. So the Ferrari is going to get here like at 1 second, which is right there. And it's not going to get to 4 until 2 seconds. And finally, it gets all the way down to 8 right here at 4 seconds. So that would look something like this. So we'd have 1001, 1002, 1003, 1004. So compared to the Ferrari's first trip, we would say this one is fast. So let's look at the two graphs together. Here is the slow one, and here is the fast one. But how can I tell just by looking at the graphs which one is slow and which one is fast? Well, to do that, let's remember a thing about graphs from math class. If I look at the slope of this line right here, I can see that compared to this line, this has a small slope. So this is a small slope, and this is a large slope. So I can see that the small slope goes with slow, and the large slope goes with fast. But this just makes sense because I can see that a graph with a small slope, if I ask the question, well, if I want to know who's going slow and who's going fast, how long did it take for them to go 4 meters? So here's 4 right here, and I can see for the slow guy it took almost 10 seconds right here to go 4. But here's the 4. To go 4 for the fast guy, it only took 2 seconds. So if it takes 2 seconds for this guy, it takes 10 seconds for that guy. This guy must be going fast. So I can see slope is correlated with speed. Large slope, fast. Small slope, slow. So I've just learned on a position time graph, slope equals speed. Well, up to now, we've only talked about the car starting at 0 and then moving from small numbers to large numbers. And when we did that, that gave us a line that goes up because we're starting at low positions and getting to larger and larger positions as time goes on. So in math class, we would say that that's a positive slope. But what happens if the car goes backwards? If it starts out far away and then moves towards the origin or towards the motion detector? Well, first of all, I realized that if the car is going to start at 8, so here we are lined up at 8. If the car is going to start at 8, my first point is actually going to be up here. And let's just say that after 1 second, as he's going to back up like this. So he starts at 8. After 1 second, he's at 7. So after 1 second, here's a point. And after 2 seconds, he's going to be at 6. So then I make a dot here. And if another second later he's at 5, because he's backing up, I'm going to be here. And if in another second he's at 4, because he's backing up, and he's here, he's going to be there. And I think you can see that if we keep doing this, in another second he's at 3, and then in another second he's at 2, and then he's at 1, and he actually arrives at the start at 0, 8 seconds later. Now if I draw a line through here, I can see that I get a negatively sloped line. So I can see that negative slope means the car is moving towards the origin, whereas a positive slope meant that it was moving away. So a positive slope, a line going upward, means the object is moving away from the origin, because as time goes on, the position measured relative to the origin is increasing. I can also see that a negative slope means we're moving towards the origin, because I start with a position far away from the origin and my positions get less and less and less. Distance from the origin gets less and less and less. Well, what would it look like if the car's not moving at all? Well, let's say it's at 4. So at the start, at 0 seconds, we're at 4. And then at 1 second, we're at 4. And at 2 seconds, we're at 4. And at 3 seconds, we're at 4. And notice that my position stays the same all the time, because I'm not moving. So if a line is drawn here, notice that it has no slope. So if speed is slope, and a large slope means fast, and a minimal slope means slow, no slope means no speed, not moving. So what have we learned here? Well, first of all, we've learned that you can represent or describe the motion of an object by plotting its location or its position versus time on a graph. And for that graph, a position-time graph, we learn that slope equals speed. So a large slope means going fast, a minimal slope means going slow. Positive slope means going away from the origin, and a negative slope means going towards the origin. What kind of motion would produce this graph with this curving line?